Hello, I'm Justin alongside Team 9 consisting of Emma, Rachel, Nick, Julia, and Allison, and we will be redesigning the Hoover Wind Tunnel Air Vacuum Model UH70400, and more specifically the vacuum head subassembly. To give a little background about the product, it is a typical household vacuum and is useful for cleaning dirt and other debris off of carpets and other surfaces. It accomplishes this by creating a vortex inside the canister to suction off the debris from the surface being cleaned.
We identified our primary customer group to be homeowners or home renters. These customers are typically have larger floor spaces with varying types of flooring that require more options for cleaning. This customer group we expect to clean their floor areas more frequently. In our redesign, these factors are addressed by our redesign of the roller brush. The new roller brush design features more spaced bristles to prevent hair from being wrapped around the roller brush as it is likely to do during regular vacuuming. Our secondary customer group that we identified for this project consists of college students or apartment renters. These customers typically have a smaller area to clean and are usually on a tighter budget than homeowners or home renters. This customer group usually doesn't see a wide variety of flooring in their residencies, so they don't require as many options for cleaning. Our redesign for this customer group addresses these factors by not only including the new roller brush design, but also eliminating the difference in trunnion sizes and some material from the sole plate. This removes the ability of the user to set the roller brush motor off, which they are less likely to use in the first place, and lowers the production cost by reducing the volume of material used.
The function of the vacuum head is first and foremost to remove dirt. This is accomplished by moving the vacuum, focusing suction, and lifting the dirt. The vacuum is moved both by contacting the floor, but also reducing the friction between the vacuum and the floor. The suction is focused by being adjusted as well as guided into the head of the vacuum. The design also needs to be able to stand on its own and be rapidly deployable, which assures the convenience to its user.
The function component mapping matrix is used to realize which components cover which function to prevent the inclusion of unnecessary parts in the assembly. The functions are derived from the FAST diagram and the part numbers from the fishbone assembly sequence. Here, each part has a function and each function is covered by a part, so no parts were wasted. Here we compared how each product function differs between our customer groups. We grouped the functions based on those that are the same for each customer group and those that are different. You will notice that pleases senses is listed in both groups. This is because both customers will require a product that pleases the senses, but our primary customer group, homeowners who regularly use the vacuum, may require more aesthetically pleasing designs than our secondary customer group, college students and apartment renters. There are opportunities for changes that we can make that would appeal to both groups and changes that would appeal to each customer group differently. Next, the product components were sorted based on whether they are a platform or can be varied as a module. Many of the platform parts are internal parts, whereas the modules are largely external components that can be varied to fit the customer's needs, budgets, and aesthetic preferences in order to optimize the product for each customer group.
From our product family design, we created two family assembly diagrams seen here. The first indicates a typical assembly sequence for all of our redesigned variations, whereas the second moves part differentiation later in time. From our assembly sequence, we performed the assembly analysis of the primary product variant as indicated by the first chart here. The total assembly time is estimated to be 46.47 seconds, and the assembly efficiency is 81%. By redesigning parts to improve handling and insertion time of the roller brush from the module part subassembly and the bearings and wheels from the platform part subassembly, assembly time was reduced to 42.1 seconds and efficiency increased to 94%. The wheels were redesigned to add alignment features for faster insertion. The base plate holes for bearing insertion, they were modified for easier bearing insertion, and the roller brush was redesigned to be more symmetric.
We decided to redesign the sole plate assembly. This includes the sole plate wheels assembly, the roller brush assembly, the motor assembly, and the belt. The sole plate wheels were combined with the sole plate to make one single assembly to decrease part count. The design of the roller brush was adjusted to make the part more symmetrical, and the number of bristles decreased to decrease the chance of parts tangling during the manufacturing process. This reduced the cost by 22.8% or 3.5 cents.
After the redesign for assembly, two parts were selected to undergo process selection. The first part selected was the polymer base plate. After analyzing the processes compatible with the polymers, the three compatible processes were machining, injection molding, and compression molding. Injection molding was selected so that we could get a good estimation of the price of the part, and because of the high economic batch size. The second part selected for process selection was the wheel, which is also made of a polymer. The only two processes compatible with the wheel based on shape, mass, sectional thickness, tolerance, surface roughness, and batch size were injection molding and compression molding. Injection molding was selected as we did not explicitly cover compression molding, and this way we could get a good estimation of the price per part.
For the redesign of our wheel, our key dimensions must stay the same so that it is still able to function properly with the rest of the vacuum. However, we were able to remove excess material and reduce the overall volume and material cost of the wheel, as well as rounding the edges and adding draft angles for the ribs on the wheel. These changes are using DfM 3, 4, and 5 to come with a total cost reduction of 14.8% or about 20 cents.
Much like the wheels, we are able to reduce the volume and round the edges of the base plate near the wheels in order to reduce material cost. Additionally, we determined that surface finish was inconsequential for the part to function, so the finish was downgraded from standard to not critical. With these minor changes to the base plate design, the cost for the part was reduced by 1.7%, which came out to 22 cents.
Our product service system starts with the purchase of a vacuum. At the time of purchase, customers will be offered a vacuum and enrollment in a recycling service. From there, the customer will receive a vacuum as well as an owner's manual covering and maintaining the vacuum in order to maximize the vacuum's lifetime, and also a phone number for when the lifetime of the vacuum is over. After this, we will arrange for pickups for when the vacuums are at the end of their useful lifetime or when vacuums need repair. From here, we will recycle old vacuums and repair damaged vacuums. Additionally, customers will also have a portal linked on the website and in the owner's manual to assess the environmental risks and benefits of recycling their vacuums and being a part of our product service system. After that, the customers will have the option to return the vacuum at the end of the vacuum's lifetime, or the customer's need for the vacuum can be returned. And from there, we will reuse and recycle. The customers can be partially refunded for working vacuums, which are revamped and sold at a discount. The vacuums which no longer work can be recycled or used for parts. In conclusion, we identified platform parts and module parts with high assembly time to create subassemblies. We identified changes to improve efficiency, and we combined parts to reduce costs. Some design drawbacks that we may have are some overall size of the vacuum, but we did not add on very much to the vacuum itself. Our PSS focuses on recycling, offering repairs, and reusing parts. And upon reflection, we can see that we seek to reduce the amount of parts used for a product in order to make it overall better. Thank you.